Okay, so I wasn't able to print out handout 6 to work on, so if you're like watching this recording, I'm really sorry. I couldn't get it to work. But it's up online. So number 1, so we're going back a little bit. We're kind of like, woo, review. What am I hitting? Oh, I'm on wires. Okay, what is molarity and how do you calculate it? So what is molarity? Hello. What is molarity represented by? Big M. Uppercase M is molarity. What does molarity measure? What does it tell you? What's it a unit of? Moles over liters. So molarity is equal to moles of solute over liters of solution. That's like sort of the fancy way of saying it. This is really just moles of whatever you're dissolving in something over the total liters present. Next semester, if you have to take Chem 2, you'll work with molality, which is kind of like this but different. So if we're measuring amount of something dissolved in a liquid, what is that? Like if salt, okay. Let's say I have 2 cups of salt water. One has a lot of salt in it. The other only has a little. Concentration. The one with a lot of salt in it is more concentrated than the one with a little bit in it, right? Okay, so I'm going to hide the answer. So what's molarity? What does it measure? Concentration. Okay, cool. So number 2, with this worksheet, I kind of just jumped straight into the math. So that's what we're going to do. So for number 2, I'm going to read it and then I'll write down what you need to work the problem. So 40.5 milliliters of calcium hydroxide is titrated into 90.0 milliliters of 5.0 molar hydrochloric acid. What is the balanced chemical equation for this reaction? So what you need to know, we have calcium hydroxide. And we have 40.5 milliliters of it. You also need to know we have hydrochloric acid. We have 90.0 milliliters, and it has a concentration of 5.0 molar. Okay. So I broke up question number 2 into steps. There's number 2, then there's part A, B, C, and D. So I did this not because it's a lot of questions. I took one question that she can ask you and split it up into steps. So the very first question is, what's the balanced chemical reaction? So we have to write the formula, and we're going to have to balance it, right? So what is calcium hydroxide? CaOH2. Is this right? Parentheses, yes. Oh, that kind of makes it look like CD. Okay, what about hydrochloric acid? HCl. Because there's this hydro out in front, you know it's just hydrogen in one other atom. when you get into like ick and us, that's when you know you're working with a polyatomic ion, right? Okay, so these are reacting together. Let's write a balanced chemical reaction. So we're starting with, starting with calcium hydroxide, or you can put whichever first. It doesn't matter what goes on what side of the plus sign, it just matters what goes on which side of the arrow. So if you want to put HCl first, you can do that, it doesn't matter. What are we going to get from this? What are always the two products of an acid-base reaction? Salt and water. So tell me what you guys like more, because I prefer one way, but I'll do whatever works for you. I like writing water HOH because it's this hydrogen and this hydroxide coming together. But if you want me to, if this is confusing, I can write H2O. What do you guys prefer? Okay, I'll do that then. And what's the salt? Calcium chloride, CaCl2. Is this balanced? How are we going to balance it? 2HCl for this chlorine here. And then what? 2H2O. So I kind of like went through that, but if you're still having trouble balancing, write out each part, like how many calciums, how many hydroxides, how many hydrogens, how many chlorines, and then balance everything out that way. From this calcium has a 2+ charge, and so that's why there's a 2 here on Zoom. Okay, so now we have a balanced equation, so now we can start working the problem. So part A, how many moles of hydrochloric acid were present? You don't actually need the equation for this. Do we have what we need in the problem to find moles of hydrochloric acid? Yes. Molarity is equal to moles over liter. We have molarity here, 5.0. And we have milliliters. What is 90.0 milliliters in liters? Mm-hmm. How many moles is that? Mm-hmm. 0.45 moles. I don't know. My advice, especially with the atoms, is like even if it's something as simple as liters or milliliters to liters, just go ahead and show it, like just jot it down, just sort of like so you protect yourself. Right. Okay, so we have 0.45 moles. Oh shoot, I should label this hydrochloric acid. So step B. How many moles of calcium hydroxide were used? So this is where we're actually going to like get into the stoichiometry of it all. This is everything else we've done up until now is just sort of like, it's like your pre-lab. I had a word and then I lost it right as I went to say it. But those are just the beginning steps. So how many moles of calcium hydroxide were used? Where are we going to start this math part? In moles of not limiting reactant. There is limiting reactant. not in this question, but in the next. Yes, we're going to start with the moles of hydrochloric acid. What this equation shows us is there's a direct relationship between the number or the amount of hydrochloric acid and the amount of calcium hydroxide, right? They're in a 1-to-2 ratio. Don't let that confuse you. We're not really like working with ratios, but what I'm saying is they're set in fixed amounts relative to each other. So we're going to start off with moles of hydrochloric acid. What's going to go on bottom? What unit? We're going to need moles of HCl again, right? Has to be the same on the bottom as the top. Where are we going to grab these moles from? The coefficients of our balanced chemical equation. We have a 2 here, so we have 2 moles. So now we're going from bottom to top, so that means we're converting into something else. What are we going to convert to? Moles of calcium hydroxide. Where are we going to find that mole? Those moles. From the coefficients, from this ratio. Cross out your units and do math, and then tell me how many moles of calcium hydroxide we used. Just because this question is only asking for, excuse me, for moles of calcium hydroxide used, and because of these coefficients, we don't have to go to grams of anything. We can just stay in moles the whole time. Does that make sense? It'll ask you for grams. Oh shoot, I don't have my key up. Yes, I got, no, that makes sense. 0.225, yeah. So with significant figures, 2, 3. That's why my answer is different. Okay. So then step C. So, okay, I take back the step C. This isn't a step, this is just if she asked you for grams, this is where you would go next. So how many grams of calcium hydroxide were used? Well, we know we use 0.23 moles, right? So what do we need over here? 1 mole. And what unit on top? Grams. Where are you going to find the grams? Periodic table. Mm-hmm. 74.1 grams. Cancel out your units. And how many grams did we use? From the periodic table, since you have 1 calcium, you'll add up 1 calcium, and then you have 2 oxygens and 2 hydrogens, and you'll just add it all together. Yes. But I'm just going to use the 17 because it's 2 sig figs. Also, if you guys see like someone message in the chat and I don't notice it, could you let me know? I always like at the beginning when the professors would ask that, I was like, just check everyone's. But now I get it. I get it. Yeah. Okay. So D, so C is kind of like an alternative if she asks you for grams, but she may go from B to D, which is what was the concentration of the calcium hydroxide? So what a question like this would look like is she would give you 40.5 milliliters of calcium hydroxide is titrated into 90.0 milliliters of 5.0 molar hydrochloric acid. What is the concentration of the calcium hydroxide? So you would have to see step D, just that question, and know that steps A and B need to come first. Okay. What was the concentration of the calcium hydroxide? So we're looking at concentration, we're looking at molarity. Molarity is equal to moles over liters. Do we have all the information that we need? Oh shoot, okay. This is all the information we have. Do we have all the information we need to do moles over liters? Yes. We have moles of calcium hydroxide here. We have milliliters, which we can turn into liters up here. So whenever you're doing something like this, always write down the formula. Even if you have to write it down 3 questions in a row, she'll still take off points if you don't. So how many moles do we have? 0.23. And how many liters? Yes, 0.0405. And what's the molarity? Oh, whoa. 5.7, 5.4. I got, or 5.1. I got 5.4 when I did. Let me redo this. Anyone on Zoom? What are y'all getting? Oh my goodness. So many points. Okay, well now I got 5.7. Okay, so we're gonna go with 5.7. 5.7 molar. How do you guys feel about that type of question? Does it help seeing it broken down into the steps?
So if it says concentration,
Yes.
but what if it has like concentration?
What do you mean percent do you mean maybe percent yield?
Like she has some questions where it'll be like, what is the percent composition of calcium hydroxide or something like that?
Percent composition. Do you have that type of question pulled up right now? Oh shoot. Percent composition. Is it asking like the percent composition of calcium and calcium hydroxide? Like something like that?
Or it'll say like you have 40 something, whatever unit is, of calcium hydroxide in this like concentration, like I don't, it's on you, I don't know what it is.
Okay. I'm sorry.
That's okay. I don't have that stuff.
Okay. So Now we're going to go into question 3. So question number 3 is part D. It's me asking a question just like this. So question number 3, 76.8 milliliters of sulfuric acid is used to neutralize 154.3 milliliters of 8.5 molar lithium hydroxide. What is the concentration of sulfuric acid? Okay. So we have sulfuric acid. What's the formula for that? H2SO4. And we know that we use 76.8 milliliters of that. We also have, lithium hydroxide. LiO8. Oh, shoot, I meant to ask you guys. That's okay. We use 154.3 milliliters, and it's 8.5 molar concentration. What's the first step? Balanced chemical equation. H2SO4 plus lithium hydroxide goes to what? Yes. And water. Is this balanced?
So you just take the hydrogens off and add it to the other one, and then take the lithium and put it on the one that you took the hydrogen.
Yep, you just switch the partners. Is this balanced?
And you have to put a 2 from LiOH
Yep.
and then a 2 from the water.
Yes. Right, yeah. Okay.
You need to put like gas or liquid or
I don't think she'll have to write that like out. You'll see it in her equations, like aqueous, liquid. Oh shoot, I should have written it out. I don't know if this one is soluble. What's the state of matter that you would put for water? Liquid, not aqueous, just liquid.
like how would she know?
I mean, it's probably good practice to go ahead and write the states of matter just to help you learn the solubility rules. So like if you write it out while you're working your homework and you make yourself go and check the solubility rules, because you'll see certain compounds coming up over and over again, and eventually you'll just sort of learn them. And like by the time you're done with your chemistry classes, you'll know that the molar mass of water is 18.02 because water's in everything and you're just going to calculate it so many times, you're just going to know it. So something like that, like if you just do it over and over again, you'll remember those. Okay, so we have our balanced equation. We're looking for concentration. We're looking for concentration. So what's our next step? What can we do with the information that we have right now? Yes.
So this type of problem, she was going over how you would go like polarity to moles to moles to polarity. Would you do that on this one?
So this is molarity to moles to moles to molarity. That's exactly the type of problem this is. So what do we already have the molarity of? Lithium hydroxide. How are we going to get to moles to lithium hydroxide? Molarity equation, correct. Oh, I'm sorry. I worry about this microphone because microphone? Sorry on Zoom if you can hear me like burp. I don't mean to do that. Okay, so we're going to use the molarity equation. Molarity is equal to moles over liters. What are we finding moles of? Oh, I already asked that. I'm sorry. Lithium hydroxide. The molarity is 8.5 molar. We're looking for moles. What is the volume in liters? And how many moles are there? Huh? No. Yes. What did y'all put in your calculator? You're good. 1.3 moles of lithium hydroxide. And so from here, keep that number in your calculator because we're going to use it in a second. You want to keep all those numbers that it has. It's 1.31155. I know she was talking last class about don't write out all the numbers because you'll run out of time. If that's what you're comfortable doing and you're not running out of time on your exams, do what works for you because that's what I do.
Yeah, me too.
Did she really?
It's sick things.
Yeah, that happened to me too. You have to do sig figs even like on your work.
Even
Even if I convert it to sig figs like in the answer, I have to do
I
sig
did
figs.
the thing for last time where you figured out all the concentrations, you divided by all those numbers, and you wrote all the numbers out, and that made sense to me, and I did it. She was she took the points off.
Yeah.
And you
Yeah.
have to
What?
mark, and those boxes have to be.
Okay, give me a second. Okay, so we have 1.3 moles of lithium hydroxide. What can we go to now? What are we looking for again? Concentration of sulfuric acid. We're in moles of lithium hydroxide, so we've gone from molarity to moles. Now we need to go to another mole. What mole are we going to? Sulfuric acid. So what's going to go on the bottom here? Yes, how many? 2. And on top? I don't need all that. 1 mole of sulfuric acid. From this, the equation. Yeah. On Zoom, she asked where this conversion came from, and it came from these coefficients. I always forget that the people on Zoom can't hear what goes on in the classroom. How many moles? 0.66. Or, yeah, moles. But we need molarity. So what are we going to do? Mm-hmm. How many milliliters? Oh, yeah, the 76. Yeah. Then you're going to do some math and find the molarity. I did 8. Yeah, I did 8.5. What did you, what,
Oh, I got 8.59.
I got 8.46.
oh, brother, okay. So 1.3155. I got 8.53. 53.
So you did 0.66 divided by 0.0768.
No, I kept all of the numbers from this.
So what I did was I did 0.65 divided by that, and that's how I got 8.5.
Because, see, this is why I like writing out all the numbers, because you're not supposed to round until the very, very, very end.
8.54, you said?
I got 8.53. That's only like 0.01
Yeah,
different.
okay, so when I kept all the numbers, that's what I got too.
Okay. So I'm going to go with 8.5. Okay. How do you guys feel about that? Awesome, because that will 100% be a math question on your next exam. Like guaranteed. Okay. So now we're going to do the limiting reactant, limiting reagent. You may see either of those names for it. Limiting reactant, limiting reagent, they're the exact same thing. So, number 4, this is the same thing that I did. I broke it down into parts that are just steps. So number 4, we have 78.9 grams of hydrogen and 61.2 grams of oxygen that react to yield water. What is the balanced equation of this reaction? So 78.9 grams hydrogen and 61.2 grams oxygen that go to water. How should I write hydrogen? H2. Yes. I have to admit, I was expecting someone to say H. I'm glad that this happened. H2. Why? Yes, it's one of the diatomic elements. This is its elemental state. This is how it's found in nature. When you breathe in, you're breathing a little bit of H2. And what about oxygen? O2 goes to H2O. Is this balanced? How are we going to balance it? Yes. Perfect.
How does H2 plus O2 equal H2O? Wouldn't you like, if it takes cross out?
Chemistry.
It's like not supposed to make sense. Like that one you're supposed to know.
Is any of this supposed to make sense? No.
I was
um,
asking because that doesn't like if you follow the rules of all the other ones, it doesn't make sense. Because you would like
yeah.
down like the
So this, in the problem, I told you, I put that it yielded water. So that's how you're going to know that it goes to water. And then you'll have to balance it accordingly, yeah. Yeah, it's not really towards the end of the semester that you start learning about how these things interact and how they form. So I'm sorry. So then part A, which reactant is the limiting reagent? How are we going to find this? Yes, okay. So let's start off with hydrogen. We have 78.9 grams of H2. What's going to go on bottom? Grams. 1.01 grams of hydrogen. And on top? Moles. 1 mole of H2. I'm sorry, I forgot the 2 here. Where are we going to go to now? Moles again. Moles of what? Not hydrogen. We're in moles of hydrogen. Not oxygen. H2O, yeah. So we're going to use this bounce reaction to do some conversions. So in the reaction, we have 2 moles of H2, and we go to 2 moles of H2O. That makes sense? Okay.
Is this for fighting the limiting reaction?
Yes. So how many moles of H2O do we get?
Why do you go to water?
Okay, so we're going to moles of water because it's limiting reactant. So you're finding out which reactant limits how much product you can get. So you have to figure out which of the reactants, so you're going to moles of water because you're trying to figure out which of these elements gives the least amount of moles of water, because that's all you can make. It's like in the PowerPoint they did the sandwich one. You have like 12 slices of bread. You need 2 for each sandwich. So you have 12 slices of bread, 2 for each sandwich. You can make 6 sandwiches, right?
I remember in class, we converted grams of H2, moles of H2, and then did the same thing for water, and then divided each one by the coefficient, and then which one's like the least number.
Yeah, but she said that's like the longer way to do it, how we might have been taught. And she said she just
Oh.
it's shorter.
So if you understood what she taught you in class, do what she taught you in class. Yeah, do whatever works for you. This is just like the way that I know it. Yeah. So 78.9 times 2 divided by 2.02 coming from 1.01 times 2. You should get 78.1. Oh. 78.1 moles H2O produced. I'm sorry, on Zoom, my mic fell off. So we're going to do this again, but for oxygen. So we're given 61.2 grams of O2. What's the molar mass? 16.00 grams O2. Goes to 1 mole. Oh my goodness, I cannot write.
Well, O2, why is it?
Oh, you're right. You're so right. Oh, why didn't you guys say anything earlier?
Well, because I don't know chemistry, so I thought it was right.
Now I look so dumb on recording. I should know this. Okay,
Yeah, I was confused. I was like H2, like that's 2 times, but
2.02, 32.00 grams. Okay, so redo this. And so on Zoom, if you're wondering what happened, I forgot it's H2, so you have to add 2 of the H's together. And the same for oxygen. Guys, don't second guess yourself. If you have a question, ask it. I'm here. Like 9 times out of 10, whenever I'm like working one-on-one with a student and they get a question wrong, they like answer it and they're like, wait, no. And then they change it and then they get it wrong. Trust yourself.
It was like 100 grams, and I've been like, yeah, that's cool.
So 78.9 times 2 divided by 4.04. Does 39.1 sound better to you guys? So here we have 32.00 grams of O2. Oh, shoot. Goes to 1 mole of O2. What's going to go on bottom? 1 mole. And on top? 2 moles of H2O. How many moles of water are produced from the oxygen? 3.8. I'm going to do 3.83 because of sig figs. So, which reactant is the limiting reagent? O2. O2 produces the smallest amount of product. So now B, I want to know how many moles of water were produced. So here's what she could do. She could give you 78.9 grams of hydrogen and 61.2 grams of oxygen react to make water. How many moles of water are produced? And you're going to have to go through this and figure out the limiting reactant, because if you accidentally do the excess reactant, you're going to get it wrong. You're going to have too much. So, B. We're trying to get to moles of water, but we already got some moles of water, right? How many moles of water are produced? 3.83. And you will figure that out just by finding what the limiting reactant is. So now C. How many grams of water are produced? So this is just mole to grams. We're starting off with 3.83 moles of water. Then we have 1 mole of water is equal to how many grams? 18.02 grams of H2O. So how many grams of water do we get? Mm-hmm. What was it? 69 point what? Okay, 0.0. Thanks. So this is what we call theoretical yield. In theory, you should be able to get this much water from this reaction based on the numbers present, right? So very last question, I promise it'll go quick. So number 5. So if it asks for percent yield, it'll have to give you what the actual yield was in the problem. Actual over theoretical. Percent yield, but that's the problem we're doing right now. Okay, so number 5, Tom Hiddleston performs the reaction from question number 4. He ends up with 52.5 grams of water. What was his percent yield? So up here is our theoretical. The actual yield is 52.5 grams. So to calculate percent yield, you're going to do your actual divided by theoretical times 100. So in this case, oh my goodness, I'm so sorry. So in this case, we're going to do 52.5 divided by 69, right? I have 76.2, but that's such a small difference. Doesn't totally matter. Okay, are there any questions over what I've done today? On Zoom, any questions? Okay, if you have any questions, you can always message me on Remind, and I'm gonna end the meeting. Y'all have a good day.